Alright, so today we are solving the course challenge for the entire Algebra 1 course. Let's go. So what do you have for the first question? Function g can be thought of as a scaled version of fx equals to x squared. Okay, right? The equation for gx. So function fx is the one given in blue, and as you can see, it has the same starting point, but it is just reduced inside. So for x value 1, where it was 1 for y for f, it has become 5x. So we can see that the function here is 5 times that of f. So if we multiply each coordinate with 5 times, we would get the answer. For y it was 1 for f, but now for g it is 5. So basically you're multiplying 5 times. So this is the equation for gx. Okay, so now we have the table compares the height of a table and the height of the chairs, both in centimeters, in several different kitchen sets at a furniture store. Can the height of the chairs be represented? Okay, so we want to represent heights, so which means height should be on the x-axis. Okay, heights of chairs, so chairs we represent as a function of heights of the table. So it means a function here, it should be on the y-axis. Now, can we do that or not? So we know that a function is defined for one-to-one relationship, many-to-one relationship. But if we find that we have a relationship like one-to-many, which means for one value of x, let's say this is whatever value of x, we have multiple values of y. In that case, we can say that this relationship cannot be represented as a function, because function is not defined for one-to-many relationship. So our job is to check the x values. So they have said chairs will be the x. We have to check that for same values of x, we have multiple values of y or not. So here we see 46, 44, 47, 46, we have same values of x, but representing or mapping to the same value of y. So 43, 48, here also we have a repetition here, 44, 44, 47, but it maps to the same value, 42, 43, 48. Okay, so this satisfies our condition, therefore we can say yes, it can be represented as a function of the table. All right, next question. What is root 4.84? Okay, so in order to solve this, we have to find the root of 4.84. So it means that 484 divided by 100 if we remove the decimal places. So this thing can be written as root 484 divided by root 100. And we know that root 100 is 10. And we have to find the, root 484. So in order to find root 484, let's see, it's 22. So 22 divided by 10 is again 2.2. So our answer should be 2.2. Let's check the exact thing. Yeah, it's 2.2. So our final answer is 2.2. Yeah, similarly. Okay, fine. Next question. When the Dragons have lost their most recent game, 200 fans buy tickets for each consecutive win the Dragons have. The number of tickets fans buy increases by a factor of 1.1. Write a function that gives the number of tickets fans buy to Dragons games after the Dragons have had W consecutive wins. Okay. So when the Dragons have lost their most recent game, 200 fans will buy the ticket. Okay. For each consecutive win, the number of tickets will be increased by a factor of 1.1. So we have to represent function where we have W consecutive wins. So it's increases by a factor of 1.1. So which means 1.1 to the power W. But because we have an initial value for 200, so it should be 200 for W equals to 0. So anything to the power 0 is 1. So it gives me 200. So this should be the answer. Yep. All right. So we have to solve 3 times function of -4. Okay. So let's see what does the function f gives us as output for -4 input. So for -4 input, we have an output for -3. 1, 2, 3. Okay, for f. -4 gives us -3. We can replace this with -3. 3 times g of -2. So for this is -2. -2 for g we have +6 g. So I can replace this with +6. So 3 times +6 is 18, and that is also, oh, we have a minus here. So we can't do this. BODMAS rule. So -3 times 3 is -9, minus 6 3s are 18. So now we have 18 negative 9 plus 18, which is 27, -27. So this is our answer for this one. Okay, so for the next question, match each expression with its value. So g of 0, g of 0. So for x equals to 0, this is not the value, open circle, this is not included, but this is included, so it's -5. For a slightly on the positive side of 0, for slightly on the positive side of 0, we would have -3. Okay, -3. And slightly on the negative side of, on the left side of 3, on the left side of 3, we have, again, we have -3. Even if it was 3, for 3 we have -3, and obviously for the left side of 3 we would have 3, and for g of 3 we also have 3. We also have -3. Yeah, for g of 3 we also have -3. So this should be our answer. All right, next question. Function g can be thought of as a scaled version of fx equals to modulus of x. What is the equation for g of x? Okay, so g can be thought of a scaled function of fx. So fx is modulus of x. So what is the difference? We have the same point, but if we take a particular value, we'll get the difference. So in order to do so, we need a solid value, good value. So this is 4, this is 3. So what's the difference? For 1, it's 1, but we can't see here. For 2 it's 2, but we can see here for 3 it's 3, but it's 4. So the difference is obviously the G is at the top, so it will have a more than one value. Then the like we have to multiply more than 1, so it's 4 by 3, I guess. 4 by 3, yep, 1.33. So this thing would be the answer would be 4/3 of that, not 3/4, because 3/4 is less than as you can see, less than 1, and that is not the case because G is above F, so it must be greater. So and C and D shows that it is transformed, shifted positive on the positive y-axis by 4, and shifted like C and D shows that shift the x-axis by 4 above, shift the x-axis by 3 above. So it shows that, you know, something like this, which is not the case. They have the same origin, it's the same starting point. So our answer should be A. Okay, fx equals to x plus 2 times x minus 4. What are the zeros of the function? Write the smaller x value. Okay, in order to find the zeros of the function, we need to put each bracket equal to 0. So x plus 2 equal to 0, and we have x minus 4 equals to 0. Basically, they're asking for the root. So we have x equals to -2 from here, and we have x equals to 4 from here. The smaller x would be -2, and the larger x would be +4. So -2 and +4. What is the vertex of this parabola? Now, we know that this is a quadratic equation. When we multiply, we have an order of 2 for x. And we know that the parabola is symmetric, i.e. the roots, where we have the roots, okay, the average of that would be the point of vertex. So -2 plus 4 divided by 2 is the x value. So 2 minus, so this is 2 by 2, which is 1. Okay, so from 1 you have 3 units to the left to get -2, and 3 units to the right to get +4. So x equals to 1 is the x-axis at the x value. But what about the y? Let's plug in here. 1, 1. So 1 plus 2 is 3, multiplied by 1 minus -4, which is -3. So 3 times -3 is -9. So it is 1, -9. All right. So select the interval where gx is greater than 0. So which means it is in the positive side, right? So this portion, and this portion. So this is from -5 to -4. No, -5 to -4 is below. This can't be. From -2 to -1. From -2 to -1, yes, it's on the greater than 0 side, and 4 to 5 is not gx greater than 0, so B is our answer. B is our answer for this one. Yep. Okay. Write an equation that represents the line. Use exact numbers. Okay, so they have given us 2 points to aid in our calculation, and this is 2, -2. This is -1, -2, -3, -3, -6. So in order to find the equation, we first find the slope, or m, which is del y upon del x. So y2 minus y1, x2 minus x1. So -2 +6 upon 2 +3. So this becomes 4, and 6 minus 2 is 4, and 3 plus 2 is 5. We have the slope. Now we want the y-intercept. So we know that y equals to mx plus c, the standard linear equation format. We have the slope, which is 4 upon 5. So we can plug in one value here. So for y, we have negative 2 equals to m, which is 4 upon 5, times x, which is 2, and then plus c. So from here, we can find the plus c. So we have calculator. I prefer Desmos, negative 2. Negative 2, and then we have negative 4 by 5 times 2. Okay, so this thing, when it gets here, it becomes negative. So negative 2, negative 4 by 5 times 2 is negative 3.6, but exact value, so negative 18 by 5. So, which means our equation is y equals to what is the slope? 4 by 5. So we have 4 by 5x, and negative 18 by 5 is our y-intercept. So this is our equation. There we go. Okay, so they have asked us to graph the function. Okay, so we'll have to graph the function, and we have calculator. So what we can do is we have to find the vertex. First of all, the vertex of this graph. And how do we do that? We complete the square, or we could just find this. We could just find the the roots as well. Finding the roots would also aid us in this matter. And in order to do so, we know the quadratic formula for finding the roots, which is x equals to minus b plus minus root over b square minus 4ac divided by 2a. And we know that a, b, c, so equals to negative 16 plus minus root over b square, which is 16 square minus 4 times 8 times 3 upon 2a upon negative b plus minus root over b square minus 4ac divided by 2a. So 2 times we have 8. Okay, so we have to calculate negative 16 plus minus divided by 8 to 0 is also 16, and we have to calculate 16 square root over 16 square root over 16 square minus 4 times 8 times 3 minus 4 times 8 times 3. Okay, so mushkila, problem. We don't have good values. B square 16 square minus 4 times 8 times 3 gives us this thing. So let's find, okay, 160. So plus minus root 160. So which means the entire thing will not be it will not be in integer. So negative 16 positive root 160 and then upon 16. Okay, this is the root, and that does not help us. So instead we'll have to perform completing the square in order to find the vertex. Okay, so if we find the vertex and the y-intercept, then that would allow us to graph this. So the y-intercept is when you have x equals to 0. So if you plug in x equals to 0, this term gets cancelled, this term gets cancelled, we have positive 3, as you can see. So I can say that one thing is on positive 3. Okay. Now for the vertex. For the vertex, we need to perform completing the square, because the root method doesn't work because it doesn't give us an integer value. So let's take 8 as common. X squared plus 2x plus 3. So 8x squared plus 8 to the 16x plus 3. Okay. Now we can write this as x squared plus 2 times x times 1 plus 1 square negative 1 square. This is 8 plus 3. Let's see whether we have preserved equivalence or not. 1 square negative 1 square gets cancelled out. 2 times x is just 2 times x, and everything is preserved. So we can rewrite this as x plus 1 whole squared minus 1 plus 3. Lifting up the bracket, we have 8 times x plus 1 whole square negative 8 positive 3. So 8 times x plus 1 squared, we have negative 8 positive 3, which is negative 5. So the vertex is negative 1 because we put this bracket equal to 0, and negative 5. So for negative 1 and negative 5 is another thing, so we plug it here, and for negative 1 we have negative 5. So these 2 points should allow us to graph this function correctly. There we go. All right, complete the recursive formula of the geometric sequence. Okay, so geometric sequence, you first find the common ratio, which we do so by dividing second term divided by first term. So 10 by 6 is 3 upon 5, 0.6, okay, or 3 upon 5, I guess. Yep. Alternatively, you could do 3.6 divided by 6 as well. It would give you the same answer. 0.6, yep. And geometric sequence has a formula for, so the first term is just 10, so it's easy, but they're asking for the nth thing, so we know that it is a, and then they have given n minus 1. Okay, so the nth term is common ratio a, and then we have n to the power r minus 1. Okay, so the common ratio is 0.6. First term is 10, and the nth term is n, and then r minus 1, the common ratio, which is 0.6 minus 1. So first time is a, second time is r, ar, and then we have ar to the power n minus 1. Yep, this is the correct one. So the first time is 10, then we have common ratio, multiply that with 6 by 10, and then 6 by 10 squared. So 10 times 6 by 10. For the third term, it gets squared. For the fourth term, it would be power of 2. Yeah. So a r to the power n minus 1, right? So a is 10 and r is 6 by 10 to the power n minus 1. This is what they are asking us, but they've already given us recursive formula. So this is the iterative one. We have to find the recursive formula of the geometric sequence. So which means a times the first times the n minus 1 times what? The first value is 10, and n minus 1 is the term, let's say 1, 2, 3, 4, fourth term. Okay, so previous term, which is 3.6, and that is multiplied by the common ratio in order to get n, 4. So we have 10 times 3.6, which is 36, but we want 2.16, so times x equals 2.16 is 0.06, which means the common ratio, which is 6 by 10, common ratio, which is 6 by 10, that thing is squared in order to get 6 by 10. Wait, 6 by 10 is this thing, but if we square this, 10 square, this is 10 for sure, but for the recursive form of the geometric sequence, we have a times n minus 1 times six by 10, I guess. Okay, let's see. 6 by 10 is just okay, simplify 6 by 10. 6 by 10 is 3 by 5. So 3 by 5. Yep. So 3 by 5, we have to write it in the most simplified manner. So there we go. Complete the recursive formula of the arithmetic sequence. So first term is 20, as we can see here, and here is we do the common difference, we add the common difference, which is 6. 26 minus 20, so there we go. And we have to graph this equation. In order to do so, we have the vertex at x equals to 1 and -4. So x equals to 1 and -4. Put this bracket equal to 0, and we get x value, and y value is given directly here, so -1. And we need another value, okay, for the graph. We will take the y-intercept where x equals to 0. So if you plug in 0 here, we have -1 squared. -2 times -1 squared is basically +1, -4, so we have -6. So we can bring this one here, this one to be -6 and this one to be 1, -4. Yeah, y-intercept is -6 and we have 1, -4. This should be our answer. For we have y 0, so okay, so -2, and we have x, which is 0, -1 whole squared, -4. We have -6, so y-intercept is -6. Y-intercept is -6. Oh, this is negative, which means the graph will be something like this. So what the thing is, -6, and this thing equals 0 is x equals to 1. X equals to 1 and this is minus 4. This is 1, this is minus 4. The vertex x equals to 1 and minus 4. So 1 is minus 4, but because it's negative, the graph would be not this smiley shape, but this but the sad face. Okay, so but this shows something else. Okay, so y equals to this thing. If we plug in x equals to 0 here, it gives us -6. So -6, 1 is okay, but the vertex. Okay, let's find the root for this one. -4. Now it's okay. 1 -4. 1 -4. Yeah, now it's okay. We plugged in the same values previous time, but the shape was not aligned with the negative sign. Negative sign means a smile, a sad face. So -4, 1, -4, 1, -4. Now it should be okay. Yep. Okay, pick the expression that matches this description. A trinomial with a leading coefficient of 3 and a constant term of -5. So constant term -5 is there, but this too does not comply. But a trinomial, which means there must be 3 terms. Here we don't have 3 terms, but here we have 3 terms. Coefficient of 3. This is the coefficient of 3, and constant term -5. So these are answers. Okay. Okay, so the temperature of a bottle of milk and a bottle of water after they are put in a freezer are represented with the following tables. Determine whether the data described the tables is best modeled by a linear function or exponential function. Okay, let's see. So for 0 we have 80. Okay, in order to do so, let's try to find the gradient. So let's take these 2 points and find the gradient. Okay, so we have calculator. What we can do is, we know that this is x and this is y, so y2 minus y1, y2 minus y1, x2 minus x1. So -0 is just the same thing. So we have gradient of this thing. So if the gradient is same, then we know that it's linear, where the gradient remains constant. So y2 minus y1 would be equal to 46. Okay, so x2 minus x1, which is 3. So as you can see, the gradient is not the same, so which means milk will not be linear function. Milk must be exponential function. What about water? Let's see. y2 minus y1, x2 minus x1, 2.5, and again y2 minus y1, x2 minus x1. Okay, 63.5 minus 75, 63.5 minus 75, 2.5 minus 0, 2.5 minus 0, 40.5, 40.5 minus 52.5, 52.5, 40.5 minus 52.5, 7.5 minus 5. Again, we don't, it's not same. There is a difference. It is negative 4.6, negative 4.8. So yeah, both of them should be exponential. Nope, water should be linear. But okay, it's almost the same. So we have to perform the, okay, so 4.6 and 4.8, but previously it was a lot. So we have to perform the line of best fit, are far being from constant, yeah. However, the constants are quite close to constant. It's not constant, but approximately they are. So there we go. It's best modeled. Yeah, it could be best modeled by a linear function, even though they are not exactly same, but approximately they are. So there we go. All right. Takuya's parents gave him $100 as a birthday gift. Since he loves board games, he spent $20 out of his present on board games at the end of each month until his money ran out. So because he is spending at a constant rate, which is $20 out of his present on board games at the end of each month, it's arithmetic sequence, I can tell. And with the amount of money that remained from Takuya's present during month n equals to represents the money he received his present. What is the n? So first represents the amount he received his present. So he loves board games. He spent out of this present on board games at the end of each month. So on the first month, initially when n equals to 0 we have 100, but when we have n equals to 1 during month 1 represents the month he received his present. So it will be 100 minus 20, which is 80, 80. And then each time you'll have to not multiply but positive plus negative 20, which is the common difference. Second term is this thing, arithmetic sequence, yep, 100. Oh, okay. So basically what they're doing is, the equation was a little bit vague, I guess, because on the first month you have $100 and he spent $20 at the end of each month. So on the first month he received his present. Initially it is $100. The first time is the amount of money that remained at the beginning of the first month since his birthday. We know that this is 100. Okay, so the formula is basically giving the beginning of the month. So if you calculate the end of the month, then in that case the first term would be 80. But because you're calculating the amount of money available at the beginning of the month, that's why it's 100, and that everything is the same. All right, we have to grab this equation. We have given in a factorized format, so we can plug this one equal to 0 and get the root of -7, and plug this one equals to 0 and get the root of -1. But the problem is it is not a straight line. It is a parabola, a smiley face. So we have to find the vertex as well, which is the average of -7 and -1, using the line of concept of symmetry, -1, -7. This thing divided by 2 is -4, so it's -4. But what is the value of y for -4? The value of y for -4 is 2/3 times, we have x plus 7, so -4 plus 7, then we have -4 plus 1, -4 plus 1, so it's -6, so -4, -6, and yeah, -4 and -6, another is -1, so -1, -4 and -6. Okay, so this is -1, -7, and -4, -6. Okay. Okay, the graph of y equals to modulus of x shifted down by 9 units, so -9. This means that it is shifted right side, and this represents shifting upside. Yeah, up by 9 units, and this means right, this means left. So new graph would be this thing, shifted down by 9 units. Okay, what is the third time in the sequence? The first time is 20, and each time you get multiplied by 3 by 2. So second term would be 20 into 3 by 2, and again 3 by 2, because third term is 45. Okay, first term, the previous term, and then the nth term. So 20 times 3 by 2 times 3 by 2, third term. Okay. Aspen has 306 green beads and 210 silver beads. For every 5 centimeter of a belt that Aspen sews, they use 40 green beads and 24 silver beads. After how many centimeters of the belt will Aspen have equal numbers of green and silver beads left? Okay, we basically have to perform two linear equations and find the intercept, find the common point. So Aspen has 306 green beads, 210 silver beads. For every 5 centimeter of a belt that Aspen sews, they use 40 green beads and 24. Okay, let's form an equation for green beads. Okay, so initially you have 306, so 306 minus, for every 5 centimeter of a belt you use 40 green beads, so which means for each one you use 40 divided by 5, 8. So minus 8x. Okay, it's for green beads. Y equals to 306 minus 8x, because for 5 centimeter of a belt you use 40, so for each you use 8. And for the silver one, you initially have 210, but for each 5 you use 24, so it means 24 divided by 5, you use 4.8. Okay, 4.8 for each, 4.8 for each. For 5 you use 24, so it's 4.8, and then you have x. Now, after how many centimeters will Aspen have equal numbers of green and silver bits left, which means the value of y will be the same. We just have to find the intersect. We just have to find the common point. So first we have 306 minus 8x. Another one is 210 minus 4.8x. Okay, 306 minus 8x and 210 minus 4.8x. 210 minus 4.8x. Now we have to see where is the common point. What is the common point? It is 30, 66. So after how many centimeters? X is the 30, so it is 30 centimeters. Okay, the water pressure on Mustafa as he dives is increasing at a rate of 0.992 atm per meter. What is the rate of increase in water pressure in atm per kilometer? So we know that the water pressure is 0.992 atm per meter, 1 meter. We have to convert this rate in atm per kilometer. We know that 1 kilometer is 1000 meter. So if you want to convert this to meter to kilometer, so we have to go from meter to kilometer, so we have to divide by 1000. So we can write it this thing as 0.992 to be 1 divided by 1000 kilometer. We can replace 1 meter with 1 by 1000 kilometer, because from kilometer to meter, if you go back, it will be 1 by 1000 times 100 meter, essentially the same thing. Now we have to calculate this thing. Okay, so 0.992 divided by 1 by 1000 divided by 1 by 1000, it's 992. So our answer would be 992. Okay, all right. A computer is sold for a certain price, and then its value changes exponentially over time. The graph describes the computer's value in dollars over years in time. Okay, how does the computer's value changes over time? The computer loses 50% of its value each year. Okay, 50% gains, obviously it's not gains, it's losing. So option B and option D is gone. Now whether it loses by 50% or 25%, we just have to check that. Okay, if it was gaining, it would have been increasing, like the value as we go to the right side, the value is decreasing. So we have to find the rate. Okay, so after 1 year we have a value of 250. This is 200, 300, 250. So it is 50%, because 50% means 100 of 500 is 250. So as you can see, it became half from 500 to 250 just after 1 year. So the computer will lose 50% of its value each year. Okay, so fx equals to 14 minus 0.5 times x, and we have to find f30. Just plug in 30 here. So 14 minus 0.5 is half of 30, and we cancel out 2 with 50 with 30, we have 15. So 14 minus 15 is just minus 1. Okay, so this will be minus 1. Okay, is 1, 5 a solution of the graphed system of inequalities? So x value 1 and y value 5. No, it is not a solution. Why? Because if in order for it to be the solution, it should be the intersection of both of those. Here we have blue shaded, here we have green shaded region. The only solution that would be accepted if it is inside this region, in the green line and outside the blue line, because blue line is dotted and green line is solid. But 1, 5, x value 1 and 5 is here. It's not in there, so that's why it is not a solution. Okay, solve for x, give an exact answer. So we have to solve for x. We do so by multiplying 0.5 with 5, so it is 2.5 minus 7 by 2x. 2.5 can be written as 5 by 2 basically, because you can replace this as half. So 5 by 2 minus 7 by 2x equals to 8 minus 4x minus 6. So 8 minus 6 is 2 minus 4x, and plus 7 by 2x 5 by 2. So basically I bring this one here by adding plus 7 by 2x to both sides. Okay, so it was negative 2x, and this becomes positive 7 by 2x. So if I change this to here, 5 by 2 minus 2 equals to 7 by 2x minus 4x. This is 1. Okay, 7 by 2x minus 7 by 2x minus 4x, and this is 2. Okay, so we have to perform LCM now. We know that LCM is 2, so 7x minus 4 2s are 8x, and we have LCM 2. We have 5 minus 2 2s are 4. Because we have 2 on both sides, we can cancel them, and we can say 5 minus 4 is 1 equals to 7x minus 8x is negative x. So x equals to negative 1. Okay. All right. Carla and Jordan were trying to solve the equation. This thing equals to 8. Carla said, I'll multiply this thing and rewrite the equation as x squared okay, minus equals to 8, and then I'll add 1 to both sides and take the square root. Jordan said the left hand side is factorized, so I'll use the zero product property. But in order to use the zero product property, you must have equal to 0, so you can't use the zero product property here. So Jordan is not right. And regarding Carla, let's see whether they're right or not. So if we multiply this thing, we have x times x squared negative x, and we have positive 1 multiplying with that, so positive x negative 1, so you have x squared negative 1 equals to 8. Yeah, you can rewrite this. Then he said, or she said, then I'll add 1 to both sides, so basically x squared equals to 9, and then you need square roots. Yep, this is the only way possible. So only Carla is correct. Solve the system of equations. So basically we have two equations, 7x plus 10y. So 7x plus 10y, and we have 7x plus 10y equals to 36, and we have y equals to 2x plus 9. So in order to solve them simultaneously, just check the intersection. So x is negative 2 and y is 5. So there's that. Okay. What is the slope of this line? The line is parallel to x-axis, so the slope is 0. Okay. If it is parallel to x-axis, then it is slope 0. Okay. Last question. The graph of the invertible function h is shown on the grid below. What is the value of h inverse at minus 1? Okay. So basically h inverse, what the main purpose of an inverse function is to switch the x-axis with the y-axis. Okay. So h inverse of minus 1 is basically the same as it's the same value that we get for y of this function, because we change x with y. So inverse would be this x would be this y. So y, for y, if you have minus 1 here, we get positive 1 here. So this would be positive 1. And that is the end for our test.